So now try to solve this quadratic equation. It looks like a very tricky one. Let me remind you of an old English saying that we should never judge a book by its cover. So please give it a try. Your time starts now. Start. So now let me do it. Like a qualified doctor, before we can prescribe the right treatment or the technique to solve this quadratic equation, we must first perform a diagnostic test on it. Yes, I'm talking about the discriminant test. So D equal to B square minus 4AC. And as you already know that this is A, this is B and this is C. So this means B square, that is 10 square, would be 100 minus 4. A is root 3 and C is 7 root 3. So now simplify this part, that is multiply the number part with the number part and the root part with the root part. 4 7 times is 28 and root 3 times root 3 will be just 3. Root will disappear. So 28 times 3 would be 84. So this will become 100 minus 84, that is 16. And 16 is a perfect square. So that means that this quadratic equation is not a tricky one. And that means that it can be solved very easily. Isn't that so interesting that the last quadratic equation we solved looked so simple and innocent but was very tricky, whereas this quadratic equation, it looks so tricky, isn't it? But it's actually very simple. In fact, it can be solved by at least 3 methods. Okay, so now I will solve this same quadratic equation with 3 different methods, one after another. So watch me carefully. Since here the value of D is a perfect square, that means I can factorize this quadratic equation directly. So simply transfer this coefficient of x squared term here. So this means root 3 times root 3 will be 3 and 3 times 7 would be 21. So that means our new constant term is 21. So now quickly tell me, what are the two factors of 21 whose sum or difference is 10? Obviously it's 7 and 3. Isn't it? 7 times 3 is 21 and 7 plus 3 is 10. So now divide both 7 and 3 by this root 3. So that means these are the two factors of this quadratic equation. Now just simply make the signs opposite and you have solved this quadratic equation. These are the two roots of this quadratic equation. See, we got them so easily. And the best part is that we always knew that we can get them easily because we had already performed this test. Alright, so now I'll solve this same quadratic equation by a different technique. That is by using quadratic formula, which is x equal to minus b plus minus root d divided by 2a. So as you know that b is here equal to 10. So minus b would be minus 10 plus minus under root d. Now d is here equal to 16 and root 16 would be 4. So we'll put plus minus 4 divided by 2a, that is 2 times root 3, as a is root 3 here. So now we can separate these roots. So that means x equal to minus 10 minus 4. Minus 10 minus 4 is minus 14 divided by 2 root 3. And the second root would be minus 10 plus 4, that is minus 6 divided by 2 root 3. So now we can further simplify these fractions. 2 times minus 7 is minus 14 and 2 times minus 3 is minus 6. And once again we get these same roots, minus 7 over root 3 and minus 3 over root 3. I'll put it down neatly. There it is. The exact same roots. So now let me solve this same quadratic equation by another method, which is first derivative equal to plus minus under root d. Now the best part is that even if you don't know calculus, that is how to do differentiation, then also you can differentiate this algebraic equation by using the EasyCal trick of faster calculus. So to differentiate this x squared term, you just have to pull down its power from the top and put it as the coefficient. So therefore, the first derivative of this term would be 2 root 3x. As simple as that. And the first derivative of x term would be just its coefficient, that is plus 10. And of this constant term will always be 0, and therefore we don't have to put anything. So that's it. This is the first derivative of this algebraic equation. See, using the EasyCal trick of faster calculus, you have done it so easily. Now put it equal to plus minus root d. Since d is 16 here, so it will be plus minus 4. And with that, you have reduced this quadratic equation into this very simple linear equation. So that means x will be equal to, take this plus 10 to the other side and it will become minus 10. Copy this plus minus 4 as it is. And now we can take this coefficient to the other side. So it will be divided by 2 root 3. And this is the exact same term that we had got in this method as well. So that means on simplifying it, you'll once again get the same 2 roots. So that means x equal to minus 7 over root 3 and x equal to minus 3 over root 3. By the way, this EasyCal trick that we use to differentiate this algebraic function is part of the EasyCal series of faster calculus. It is a collection of such simple but powerful tricks of doing differentiation and integration. On learning them, you will instantly become a king of calculus. So now I'm done with this video. But before I end it, I would like to give you few historical facts. This magical formula of solving the quadratic equations was given by a great Indian mathematician in 1500 BC. That is 1500 years before Christ was born. So that makes it 3000 500 years old, approximately. But the most surprising part is that till date, very few people in this world know that this formula exists. It is included in the ancient book Vedas, and that is why it is called Vedic formula. Now coming to this quadratic formula, this one. Now as you know that this is the most popular or the most preferred way of solving the quadratic equations. And do you know who gave this formula? Yes, another great Indian mathematician. His name was Sridhar Acharya. He gave this formula in 1025 AD. In his book Bij Ganita. Ganit is the Sanskrit word for mathematics, and Bij means algebra. So Bij Ganita would be translated as algebraic mathematics. And this technique of direct factorization was given by not so great Indian mathematician by the name Scheherazade in 2008 AD. So now that you have mastered all these amazing techniques of solving quadratic equation, I can say with confidence that there is no quadratic equation left in this world that you cannot solve easily. By the way, if you are curious to know who this not so great Indian mathematician is, it is me. Believe me, I really feel embarrassed to reveal my identity like that. For a true mathematician should be like this unknown mathematician who gave to the world this amazing formula without letting anybody know who he was. In fact, I took this technique of transferring this extra coefficient and then simplified the subsequent steps so that you can factorize the type 2 quadratic equations really fast.